Hey there! So last time we learned how you can save your data back to data lake from Azure Databricks. And basically that will be the process to transform your data. Read it from data lake, do some magic within Databricks and save it back. And the question is, can we automate it somehow? Can we make some of the steps less manual? And the answer is yes. And that's the topic for today. So let's get started. Alright, so let's talk about automating some of the steps in our BI flow. And I will start with showing our typical BI flow. I know I've done this many times, but it will help you to understand where and what part of the process I want to automate. Alright, so basically everything starts with various types of source data, like CSV files, JSON files, XML files, and so on. And I know you know this stuff very well. Let me just repeat that. Apart from various types of files, we also quite often have to read data from various types of databases, like Azure SQL database, MySQL database, SQL Server, and so on. And what also we often have to do is to read data from various types of APIs. And all of this stuff, this is our source data. And we know already that we don't want to build our reporting solution directly on this source data. No, we want to ingest it to Azure, to a data lake, and then build our source solutions on top of this ingested data. And whenever we are ingesting the data, we need to have some kind of a place where this data would be stored. And in our case, it is just Azure Data Lake Gen 2. So that's our place to which the data is ingested. So it flows like this. And the process, this green one, it is called ingest or extract. And we can use multiple services to do the job. And the one that I use the most often is simply Azure Data Factory, because it does the ingest process really well. Then, when we are saving the data in a data lake, we want to organize it somehow to avoid this data swamp. We want to have these nice layers, nice zones with different roles of data processing, so everyone would know what quality of data it can expect at various stages. So we will simply split our data lake into multiple layers. And now, number of those layers, it's up to you. You don't have to follow this bronze, silver, gold pattern. And again, that's something that I've covered previously. Anyway, usually the first layer that you would pretty much always have in your data lake is a raw layer, or landing, or ingest, or bronze. The name is not important. What is important is that you will keep here your files, your data as files, using the native format. So for example, if you ingested CSVs, then here you would keep your CSVs. And again, you know that, well, this file format is not optimal for data analytics. And there is a way better one. Mainly I'm talking about Delta Lake. So one of the next steps that you would pretty much always do would be to grab your data and convert it to this Delta format. So the next layer in your data lake, well, you would use Delta format here, but you will again store your files, but no longer using native format, but transformed to Delta. And if you would follow Microsoft best practices, you would call this layer conformed or silver, depends on which naming convention you would like to use. And now it's up to you to decide if you want to add some more transformations to this step, or you are just changing the data type. Anyway, what has to happen is this step. When you grab the data from the row layer, convert it to delta, maybe with some other steps, and save it to another layer. And that's the process that I would like to automate. And that's the process where Databricks Autoloader is very useful. So Autoloader can be used in this place. And actually, I've been using Autoloader here, and it's a really good choice for this place in our design. All right. So once we know where this Autoloader can be used, let's start to use it. So let me jump into Databricks, and here I have some notebook prepared. That right now it has only a single cell, and I will explain it what it does in a second. Because Autoloader, it is just a feature of Azure Databricks. It is not a separate service that you have to provision. No, it's just one of the features that are available by Databricks. And what I have in my data lake is like this. So inside my row container, what I created is this Autoloader input directory that is empty right now. And I will simulate data factory that it is put in the files here. I will do this manually just to make it faster. But imagine that this is a automated process that we've got let's say daily processing that connects to some data source using data factory. It grabs the data and it just saves it here as CSV files to this Autoloader input directory. And then we would like Autoloader to automatically detect those new files, pick them up, process, and save them as delta in a different location. And this different location, in my case, will be confirmed container, and here we would have a brand new directory created in a second. And apart from that, I would like to register this newly created data in my Databricks catalog, so I could easily use it in my queries. And actually, let me just upload the first file that we'll be using. And let me show you how it looks like. And today I will be using CSV files because they are the simplest ones to show how Autoloader works. So in my case, this first source file, which is just a simple CSV file that contains 3 columns: first name, last name, and age. And it has 2 rows. So nothing fancy, but it will be enough to show you how Autoloader works. So let me upload the first file here. So let's simulate that this is the task that was done by Data Factory. All right, and now let's go to Databricks and let me explain this code. So first of all, I'm importing some functions that I will use throughout this code. And actually here I'm using Python to configure this Autoloader step. Then I am defining some variables that will be used later on. So first of all, I am defining a path that will be used as an input location for Autoloader. So that's the place where I just manually uploaded the file. Then I've got a target path. So that's the place where the converted data to delta format will be saved. That's my confirmed layer on my data lake. I've got yet additional path that points to a checkpoint container. That's something that is needed by Autoloader to track its progress, and I will get back to it. And finally, I've got the name of my database and table that I would like to use in my Hive Metastore catalog. So the data that we'll be processing should be registered as Autoloader demo table inside PetrTDemo database. And then the actual processing starts. So I'm using Spark readStream command. That should give you a hint that Autoloader, it uses streaming under the hood. And I know we didn't cover streaming yet, but that's fine. You can even forget that streaming is involved. Simply, it's just a feature that is used internally by Autoloader. Then, by using this format cloud files option, we are telling Databricks that actually we want to use Autoloader because that's the format that is used internally by it. Then in the next line, we've got to indicate, alright, but what is actually the format of files that will be ingested, that will be processed by Autoloader? And in my case, it is CSV, because I just uploaded a CSV file. And Autoloader, it can process other file types as well, like CSVs, JSON, Avro, Parquet, and some other ones as well. So pretty much the most commonly used ones are covered. Then I'm providing a path where schema of the data that is processed by Autoloader will be stored. And it is stored in my data lake. And later on, I will show you why this schema is important. Then I'm asking Autoloader, just please go to this location on my data lake and just load everything that is stored there. Just read all columns from those files, add some new columns like source file that should store information about the file that was used as a source for a given row, and also add a column called processing time that will contain a date and time when the processing happened. Then, once you have the data, please write it somewhere. And this somewhere is, well, write it to my data lake, to this confirmed location, to this confirmed directory. And in the meantime, please use this checkpoint path as a place where you could record your progress. So if something bad happens, if this processing stops for some reason, Autoloader would be able to restart it from the place that it stopped. Then I'm asking it, please repeat the whole process every second. So just run it continuously. That's how streaming works. And finally, please register the data in the Hive catalog table using this piotrtdemo.autoloaderdemo table name. So that's what this code does. So actually, let me run this. And of course, I've got to start my demo cluster. So let me stop for a second and let's wait until it's up. Alright, so cluster is up and this cell is being executed. So let's see what happens. So during the first run, it will take Autoloader few seconds to initialize everything, to process every step that we asked it to do. And in a second, we should see something. So actually, let me grab the name of my table that was registered, I hope, in the catalog. Let me add a new cell. Let me switch it to SQL. And let's see if anything is already available in this table. So let me just use select statement, like so. And hopefully we would see 2 rows there. Not yet, so let me run it one more time. Maybe this time the Autoloader was already able to process our first file. And there it goes. See? We have some data already available with this first name, last name, and age columns that were retrieved from our CSV file. Apart from that, we've got this strange rescued data column. I will get back to it. And apart from this, we've got 2 additional columns, like this source file that tells us what was the source file from which this particular row was read, and secondly, when this file was processed. So, alright, the initial step was done. So let me continue simulating data factory, that is uploading new files to our input container. So let me upload a second file and I will show you how it looks like. So in the second file, well, we just add two additional rows, Anne and John. And let's see if it will be picked by Databricks and Autoloader. So let me drag this file, let me upload it. And because Autoloader is running every second, it should automatically pick and detect that, hey, this new file has just appeared. It should process it and it should add its content to our Autoloader demo table. So if I run this select statement, I should see 4 rows. So let's verify if it's true. And yes, you can see those 2 additional rows. And basically that's how Autoloader works. You just configure it once, and you should see how simple it was, just a single cell. And then you can basically forget about it and just upload your files to a specific location in a data lake, and Autoloader will take care of the rest. And whenever some data is available there, it will just process it and make it available in your Delta table, like we can see here. So later on, the next steps of data processing could be already done on this table, so we can forget about this data lake location. And actually, let's verify how this table looks like in our catalog. So let's jump to the catalog, and we should see this Autoloader demo table that was just created. And if we go to details, you can see that indeed it is an external table and the data is located on my data lake, in my conformed container. So let's double check this on a data lake. If we go to this conformed container, we can see this Autoloader output directory that stores data that was read by Autoloader and saved here as Delta. Great, so that's how easy it is to automate this step of converting your source files to a Delta table. Super easy, super cool. Now, it is quite nice already, but take a look at our data. That actually every column has a string type. And we know that, well, our age is probably not a string, it's a number. And depending on your requirements, maybe you would like to convert the data types at the same time. So the data that you would save to this conformed layer, you would like it to be strongly typed already. So let's see how it could be done. So I will stop our Autoloader, our stream, because it's constantly working. So let me just stop it. All right. Let me remove everything that was done so far. So let me simply copy this path, this code, and I will run those 3 commands. So the first one would just drop my table, and those 2 would just remove data from my data lake, because I would like to start from a clean environment. So let's run this. All right, so it's done. My Autoloader output directory has disappeared. And let's simply go to the input container, input directory, to be more precise, and let me remove the second file. Let me just leave the first one, so Autoloader could infer the schema at the time it runs. Alright, but how can we infer the schema? So instead of treating everything as a string, we can ask Autoloader and Databricks, please take a look at this data and try to guess how the schema looks like. And to make it work, I will simply uncomment this option. Infer column types set to true. So as you can guess, this time Autoloader will try to use a proper data type for every column. So let me run this time. Let me run it one more time. The whole Autoloader stuff, which again goes to my input directory, it is reading all data that is available there. At this moment it is just a single file. It will try to infer the schema based on the data it has, and it will save the data to a data lake, to this confirmed directory, and at the same time it will register the data in the Hive catalog. So let's see if already we can see some data in our table. And this time we should see only 2 rows, because again we have only this single file processed. And yes, we can see 2 rows, and at this time you can see that the type of H column was changed from string to integer. So Autoloader was able to look at the data, see that those values here, they look like integers. So it decided to use integer type for this column. Now, you don't have to rely on Databricks' ability to guess the schema. You can provide it explicitly if you want. Or you can provide a schema hint, in case of which you would just tell Autoloader, hey, just guess the schema for various columns, but for this particular one, for example for H column, just make sure to treat it as integer or double. And it is useful in cases when you know better, because maybe you know that this H column, it should be treated as a double, but the all sample data that you have at this moment, it contains only integers. So by using schema hints, you can force Autoloader to use a particular data type. And let's just upload a second file to just show and prove that everything is still working. So let me upload a second file. And in a second, we should see 4 rows in our table once this new file is processed. So let me verify it. And there it goes. We've got those 2 additional files. And this time, this H column is just treated as integer. So super simple. Great. So let's move forward with some use cases. In ideal world, our data will not change our schemas, but unfortunately that's not the case. Our data sources change, and let's assume that one day they start to produce CSV files with an additional column like this gender. This is the 4th column in our files, and so far we don't have this column available in our table. So how would Autoloader react if it receives a file with some additional columns? So let's verify it. So let me go into our row container, into input directory, and let me upload this file with this new gender column. And let's see how it impacts our Autoloader processing. And you can see that it instantly failed. It failed with an error that unknown filed exception was erased. New fields in file. Unknown column called gender. Alright. So first of all, it means that Autoloader knows what schema it expects. So it means that it has to keep the schema somewhere. And in a second, I will show you where it is. And what's also important is that it says that Well, it can be fixed if you just retry the processing. So we'll do that in a second. But getting back to the schema. So when we configured the autoloader, there was this option, this schema location. So we told autoloader where it should keep the schema of the data that it is processing. And it is here in my checkpoint location. We've got this schemas directory. And actually right now we've got two versions, 0 and 1. So this was the first schema that was used without this new gender column. And this 1 file, that's the schema that already contains this gender column. And actually those are just JSON files that you can view. And somewhere here you should see this new gender column that it was detected. So that's how autoloader keeps track of the schema, so it can detect when something changes. So it is super cool that autoloader is aware of the stuff it expects to receive. And if something happens, it can react. Alright, and the error says that, well, if we retry processing, then it should work. Let's find out. So let's run the autoloader processing and let's see what will happen. Whether this time it will work. And it failed. It failed again, but this time with a different error. That a schema mismatch was detected when writing to a delta table. So it is a different phase of the processing. So this time autoloader was able to read the source file. It was fine with it. It somehow managed to process this new gender column, but the processing failed when we tried to save this data to a delta table. Because again, this delta table, our target location, it knows what data it expects. But from the episode about delta format, you should remember that one of the nice things about delta is that it allows for schema evolution. It allows for our data to change over time. And it is super easy to enable it. So basically, I will uncomment this merge schema option. I will set it to true, which will tell Databricks that it's fine if our data changes. Just incorporate those changes. And now, before I do this, let's verify what data we have right now. So we still have those 4 rows, data from 2 files only. So let me rerun autoloader processing. And let's see if this time it will be able to process this new file with additional gender column. So let's see how it goes. And basically, let me rerun our select statement to see if we have any data, because there is no error so far. So fingers crossed, everything is working just fine. So let me run it. And yes, we've got those 2 new columns, Marco and Jane. And if I scroll to the right, you will find a new column that was added, this gender one, that was available only in the latest file, which is set to male and female for last 2 rows, and for those old rows, it is just set to null because we don't know what value should be set there. Which again is a super cool feature that our both autoloader and delta formats, they can handle changing data, changing schema of our data. And now, this default behavior of autoloader, maybe it's not optimal in your case. And fortunately, we've got 4 modes we could use for autoloader. And the default one was this add new columns, which basically means that if schema changed between 2 consecutive runs, our autoloader will fail, just like we saw a few minutes ago. But those new columns were added to the schema. This new gender column was added to our schema. And then we were able to retry the processing, and then it worked just fine. Now, if you don't like this approach, maybe you would like to change it to the rescue mode. In this case, the schema will not change. It will not evolve automatically. Also, our processing will not fail. It will just continue to work. But the thing is that those new columns, maybe you just might not want to dump them or lose their values. And in case of this rescue mode, those additional values will be stored in this rescued data column. So later on, you will be able to process it, which is super cool. And I will show it in a second. Then you've got this fail on new columns mode, in case of which, well, if the schema changes, the stream will fail. And it will not be able to start again until you just update the schema. Or if the file that is causing the errors is removed. So it is kind of a strict mode. And finally, none mode is, well, if anything changes, I don't care. I don't change the schema. I ignore those additional columns. I just ignore all those stuff that were added in the meantime. But it might be it might not be the best option for you. So let me just show you how this rescue mode looks like. So let me stop our processing, our stream, and let me change this evolution mode to rescue from the default one. So let's do this. Let me start the stream, and let me show you a new file that I will just upload in a second. So I've got this source file number 4 that has yet another column, salary, with a value of $10,000, let's say. So let's see how this time in this rescue mode, Autoloader will react. Previously, in the default mode, it failed, and it updated the schema automatically. Here, it will be different. So let me go to the location to which we've got to upload our files. It was this Autoloader input, and let me upload our file, like so. And let's see what will happen. And again, because Autoloader is scheduled to run every second, it should detect this news file in no time. So if I rerun my select statement, it should already see this new data coming from the 4th file. So let's run this. And yes, we've got a new row, this Tom Boss, that is coming from file number 4. But please note what changed. This rescued data column, now it contains some data. So basically, every column that doesn't fit the schema will be stored here. And in this case, it is just this salary column with this value of 10,000. So maybe one day your data engineer will say, well, actually, we would like to have this salary data incorporated inside our schema. So what they could do would be to simply add a new column and then parse this rescued data column and retrieve the value and store it in the new column. So this data is not lost. That's the most important thing about this rescue mode, that if you need this data in the future, it is there. So that's yet another cool feature of Autoloader. And it is still running. So let's now see and check how it behaves in case of errors. So let me show you my last sample file, which has some stupid data. So here in the H column, I am passing a word 30. And Autoloader is not yet smart enough yet to convert this 30 word to a 30 number. No, maybe in the future. But right now, it will not be able to convert a string to a number. So what will happen? So let me just upload this new file and we'll see. So let me grab the file, let's upload it, and let's see if the stream will fail, if the autoloader will fail or not. Is it able to process this file with this stupid data? So basically it didn't fail. So let's see what is stored inside our table. And we've got this new row, this test user. So that's the row that contains this 30 word set as age. And apparently autoloader was not able to convert it to a number. So that's why we've got null here. But again, this data is not lost. It is available in our rescued data column. So again, data engineer might take a look at this data and realize, oh come on, this source data is rubbish. So let me clean it just by updating my test row and just put in here a 30 as a number. So that's how this data could be cleaned and fixed. So that's super cool. Now, the thing is that, well, autoloader is using streaming under the hood. And streaming, well, it is meant for cases where we've got a constant stream of events, constant stream of new data that we've got to process. And that's true. But what if we have a batch processing like we have right now? Let's say that our data factory, it is triggered to run every night at midnight, and then it uploads new files to the location that is monitored by autoloader. So it means that for the most of the day, this autoloader is just running without doing any actual work. And it is using my Databricks cluster under the hood as a compute layer. So I will have to pay for this work when actually nothing is done. So maybe I would like to change the processing somehow, so my autoloader will not run constantly and it will run on demand. And yes, that's possible. So let me stop this. Let me stop the stream. And let me change the trigger of my autoloader. So right now it was set to run every 1 second continuously. And I will change it to a mode called available now equal to true. Which means that if I run this cell right now, then autoloader will start. It will see if there is any new data to be processed. If yes, it will process it, and then it will stop. It will no longer be running. So let me prove it, how it works. So let's run this. It's waking up. It is checking in the location if there is anything to be processed. There was no new files, so it just stopped. So there is no work happening on the cluster right now. And because my demo cluster, it is configured with auto termination, then in a few minutes it will just shut down and I will be not paying for this compute power, which is again super cool. Now you might be wondering, alright, but how is autoloader able to tell what files it processed and what file it has to process? And basically there are two things we've got to consider here. So first of all, we've got this checkpoint thing that is used by autoloader to keep track of the things it already did. So that's where it saves the data. So if something bad happens, if it restarts, it will know exactly where it finished, so it could resume the work from this moment. So that's one thing. Secondly, we configured some input location for autoloader, so it has to detect somehow that something new was uploaded to this location. And actually there are two modes that autoloader could use. The first one, a simpler mode, is simply a directory listing mode. In this mode, every time Autoloader starts, it will go to this particular location and it will check if there is any new file that it hasn't processed yet. It will just list everything that is stored in this directory. And it's working just fine. The thing is that if you've got a lot of files, then this listing process, it might take some time and it might cost you some money. So maybe it is not the optimal method in case you've got really a huge number of files. And to solve this, we've got another mode called notification. And let me show you how it works. So actually, let me draw something. All right, so let's jump into whiteboard. And let's revisit our scenario. So let's say that this is our data lake. So ADLS Gen 2. And some process is uploading files to it. Let's say it is a data factory. Like so. And you should remember by now that in Azure there are many events created when various things happen. For example, when some file is uploaded to a data lake, this new event called, I believe, blob created is just fired. And there are multiple things that could react whenever this event happened. And under the hood, it is using this event grid stuff that is used to manage those events, to subscribe to them, so you can react if something happened. So for example, we use this stuff whenever we wanted to start data factory processing. So this is ADF. One of the triggers it has is this event trigger. So for example, whenever a new file is uploaded, you can subscribe your data factory to this event and then start the processing. So it will be able to grab this file almost instantly. And Autoloader is using the same mechanism. It can subscribe to those files created events from this particular location. And whenever it happens, Autoloader will use a queue that is a part of a storage account. We've got those 4 services under a storage account, like blob storage, queues, tables, and files, and queues will be used here. And all of those events will be saved to a particular queue as messages. And those messages would contain information, what file was created, where it is stored, and so on. So later on, when Autoloader starts, then instead of going directly to a data lake and listing all those files, it will simply go to a queue and then process those messages one by one. And based on the content of those messages, it will know exactly what file from where it has to process. So that's how you can configure it in a more reactive way, just to process only those files that were explicitly created. And this mode, well, it is useful when you've got a huge number of files. So that's something to consider. All right, so to summarize, when you're building your data processing solutions, you don't have to write everything by hand manually. You can automate some of the steps. And today I covered the Autoloader feature. It is a part of Azure Databricks that you can use to react to some file appearing on a data lake. For example, you can just read it, convert it to Delta format, and just save it to another layer. Or if that's what you would like to do, you can also apply some transformations on it. It's up to you to decide. But once you configure it, basically you can forget about the process. It will just work automatically for you, which is super handy. And that's it for today. Thanks for watching and see you next time. Take care.